Chapter 6, Section 4 is about properties of special parallelograms. So by the end of this lesson, you should be able to prove and apply properties of rectangles, rhombuses, and squares, and then use those properties to solve some problems. So remember that a parallelogram, what we spent 6.3 talking about, is just a special type of quadrilateral. A quadrilateral is a polygon with 4 sides. So remember, a parallelogram meant that it had 2 pairs of parallel sides. So this was our definition, and we wrote it like this: parallelogram ABCD. So you had to have 2 sets of parallel sides. So another type of a special quadrilateral is a rectangle. And a rectangle is one that we're more familiar with, but it has 4 right angles. So every single one of these angles is 90 degrees. So some properties of rectangles. If a quadrilateral is a rectangle, then it's also a parallelogram. So that tells us a lot of things. Remember, parallelograms mean that we have opposite sides that are congruent. It means that we have opposite sides that are parallel. So this is parallel to this one, and this one. It tells us stuff about the angles. Remember that this angle here has to be congruent to that one there, and then same with these, but we know they're 90 degrees, so we know that's true. And then the same side supplementary angles, but again, they're all 90 degrees, so we know that that's true. So the 2 big things are that you have opposite parallel sides and congruent parallel sides, or opposite sides. And then our other property is that if a parallelogram is a rectangle, then its diagonals are congruent. So AC is the same length as BD. So let's do an example. The rectangular gate has diagonal braces. Find each length. So the first one we got to find is HJ. That's up here. And because I know this is a rectangle, I know several things. I know that the opposite sides are parallel, I know the opposite sides are congruent, and I know that all of the angles are 90 degrees. So if G to K is 48 inches, that means H to J also has to be 48 inches. And then the other one they want us to find is HK. So that's this length right here. And remember, we know the diagonals are congruent. So they tell us that this part right here is 30.8. So that means from J to G would be 2 times 30.8, or 61.2. And then because this one right here is 61.2, the one we're looking for also has to be 61.2 inches. So our next special type is a rhombus. A rhombus is kind of a diamond shape. That's chances are what you know it from, is a quadrilateral with 4 congruent sides. So all of these sides have to be exactly the same. Now these angles don't necessarily have to be 90 degrees, but sometimes they are, and we'll talk about that in a second. So this one, you could write it like this with all of these congruent, and that's chances are what you've seen a rhombus look like before. So here's some properties. If a quadrilateral is a rhombus, then it is a parallelogram. So remember, that means opposite sides are congruent. It talks about the angles here. You know, this one's congruent to this one. Same thing with these. And then you know that these are supplementary, and you could go all the way around. They have to add up to 180. And then if a parallelogram is a rhombus, its diagonals are perpendicular. So these form a nice 90-degree angle. And then if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So this goes through and cuts those 2 angles in half. These 2 angles are congruent. And then because of this up here, we know that 3 plus 4 and 8 plus 7 have to be congruent as well. And then you notice we make a bunch of triangles with these. So of course we're going to use all of our theorems to do some proving. So let's say I give you this rhombus here, JKLM, and you need to prove that JL, this right here, bisects KJM, so this one here, and it bisects, and that KM, bisects JKL. So this one here and this one here. So let's write down what we have in a nice 2-column proof. So we know JKLM is a rhombus. So the only thing that we know when somebody tells us we have a rhombus is that all the sides are congruent. So I know that KL is congruent to LM, is congruent to MJ, is congruent to KJ. And that's the definition of a rhombus. And now once we know that, take a look at what we have here. We got a bunch of triangles. So if I want to talk about some bisecting things here, I'm going to use the reflexive property and say that JL has to be congruent to JL. So now I have these two triangles here. I got this one and this one. And because I proved that this and this are congruent and this is congruent to this, I know that triangle KLJ has to be congruent to triangle MLJ. And that's by side, side, side. So once I know that, I can use CPCTC to prove that all of these angles are congruent. 1 has to be congruent to 2, 3 has to be congruent to 4, and then this angle up here has to be congruent to that one there. So let's make another 2-column thing over here. I know angle 1 has to be congruent to angle 2, and that's CPCTC. And I know angle 3 has to be congruent to angle 4. And then because I proved that those two are congruent, that tells me this first thing right here, that JL bisects those two angles, because it gave me two congruent angles. So I've proven that JL bisects angle KJM and angle KLM. And that's by the definition of bisect. And then I can use the same logic to prove that KM bisects the other one. So I'd have to prove that these triangles are congruent, and then I get that these angles are congruent in here, yada, 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 definition of bisect. So let's do an example problem. If I tell you that this thing right here is a rhombus, we need to find each measure. So remember, that means that all of these sides are the same length. So the only information they tell us is that CG is 5A and that GF is 3A plus 17. But I know those two things have to be equal. So I can use that to solve a nice little algebra problem. We get that A is 8.5. So then when I plug that back in, I can do 5 times 8.5, and I end up with 42.5. So that means all of these sides have to be 42.5. So when they ask us for CD, even though it's up here, I know it has to be 42.5. Whoa. And then they tell us some more information. If the measure of angle GCH, so GCH, this one right here, is what we need to find. And they tell us that GCD, this big one right here, is B plus 3. And then they tell us that CDF, so this one right here, is 6B minus 40. So what we have to remember is that if you have two angles right here, like this one and this one, they are supplementary. So I know that this B plus 3 plus 6B minus 40 has to add up to 180 degrees. And that goes back to the definition of a parallelogram. So I end up with 7B's minus 37 equals 180. If I add 37 to both sides, I get 217. And then if I divide both sides by 7, I get 31. So remember, that is what B equals. So this whole big angle up here is B plus 3. So that means it's really 34 degrees. And remember, they asked us to just find this angle down here. So you have to remember that CF bisects that giant angle there. So we have to cut this in half. So we end up with 17 degrees. So the last one we got to talk about is a square. A square is a special quadrilateral with 4 right angles and 4 congruent sides. So it has 2 of the conditions. It's like a rectangle and a rhombus put together. In the exercises, these we're going to do in class tomorrow. We're going to prove that if a square is a parallelogram, a rectangle, and a rhombus, it kind of fits like all 3 categories there. So we're going to do that tomorrow in class. So this last proof, I want you guys to try this one on your own. I give you a rhombus and then I give you a diagonal, PR. So remember that does some bisecting here. You need to prove that RQ, this one right here, is congruent to RS, this one over here. So make a 2-column proof, give this one a try, and we'll go over it in class tomorrow. So you should be able to prove and apply properties of rectangles, rhombuses, and squares, and then use them to solve some problems. Make sure you write down any questions you have, and we can go over them in class tomorrow. Have a good night.